Hello? Question mark? Lots of eager beavers already here. How are we all doing? Harand, Connor, ZZZ by the way, ZZ, AC, Mr. Bowblocks, Armo, hello. Armankara, hello. Anyone on? Either Twitch is quiet or no one is here, which would be sad. Pretty sure I updated the schedule. Dennis, empty. Pim, hello. Quacko, there we go. Now it's a party. Also resubbing for 13 months. Been hanging around here for over a year now. Still not bored. Looks right. It's gonna look. It's gonna be the best triangle you ever saw. Julian, hello. Mr. Liquor. Sure. Hello. Right, okay. Quite a lot to do today. I want to render a triangle, which doesn't sound like a lot, but I want to set up the modern ASDO infrastructure. So I guess my understanding of OpenGL is that the driver does an awful lot of magic for you, and that magic has a certain amount of overhead. So the kind of tail end, I guess, of the OpenGL spec before they started working on it was to add a bunch of stuff which minimizes the GPU, CPU overhead, minimizes the driver overhead. So we're going to be doing as much modern stuff as we can to reduce that overhead, and we're going to render one efficient triangle. Why is this? I wanted my auto timestamp thing to work, and it is not, which is really sad because I need those shorts. Oh, my stream deck is having a mad one. The log session is currently active, but it sure ain't. Okay. Can it not be active? I want to spend like 0 time fucking around with this. Okay, fine. We'll just have to shout out interesting timestamps. It will be a deferred renderer when I get there, but for today, let's just triangle. It's going well. Hello. It will be a multicolored triangle. Okay, so last stream we constructed everything we needed for a shader. So now we need to combine that into a program. Then we need to probably write a simple super thin renderer class that we can just slap in here and call. Then we need to do something called vertex pulling, which allows us to slap all of our vertex data into a buffer and then kind of pull that into the shader rather than use a VAO, which is more overhead. Quacko, first, hello. We're doing this scratch, but also heavily cribbing from the previous one as well. So it's kind of still from scratch, or at least code that's been written live. I've been copying a few things here and there. Okay, so we can create shaders. So I think the next thing we need to do. So in the last series, I called this a material, and I think that was wrong because it was a program. A material kind of is I would say more abstract term, which allows you to set properties on the thing being rendered. So like, I don't know, the specular amount and all that kind of rubbish. So I'm going to rename this to program, and I might just write this one from scratch anyway. It's a bit of a warm-up exercise because I think we might want to change a few bits anyway. So let's do so let's create a new file. Let's do source graphics program.h. I'll have me a program once. I'll have me a namespace UFPS, and then we'll have a ship. We're not that. Right, nailed it. Ship it. Nando's, nice. I've heard they've put a restriction on the free unlimited free sugary drink refills. But you got a license for that. So basically, what this is going to do is this is going to take in graphics our shader, and then we'll have a program which will take program and take in a const shader vertex shader and a const shader fragment shader. I like to kind of build out the header file first. Matthias resubbing for 8 months, thank you very much. And then pretty much all we're going to want to then do is have like auto use. That's kind of it for now, right? And then we're going to need in here utils. It's open source. It's not an engine, but it sure is open source. Auto release. Oh, actually, that reminds me. Poor Git hygiene for myself. Let's do hello. Let's create a branch. And hello triangle today. Bang code. Yeah. And then we're going to have a auto release GL uint, which I need to include the header for, and then some sort of handle. Let's include graphics. Nope, get rid of that. Didn't want that. OpenGL. Okay. That's basically all you need for the program. Obviously, if we wanted to like have some sort of interface for setting uniforms and stuff like that, we could build that out here. But for now, I'm kind of happy to which Clang label are we talking about? Craft hello. So my aim is not to build an engine; it's to build a game. So only writing the code we need for that game. So it will, I guess you could kind of think of it as a very like half-baked engine. So as an example from like the last stream, the last project when we were writing like the maths classes, Vector didn't have like a sub for quite a few streams because we didn't need it, and I wasn't like building out a fully fleshed Vector class. I was just building out what we needed, and that will continue. That kind of ethos I want to continue through this. So we're going to try and only write code that we need rather than being generic, you know, rather than trying to be all things to all people. Oh yeah, that's cool. I did, and also I did mean that. Source graphics program at CPP. Let's bring in our graphics program. We'll have a namespace. Treat ourselves. Oh, that's painful. And then we're going to have hash include. We're going to want graphics OpenGL include graphics shader. Everyone's already fed up of me not being able to type that. And program. Okay. Cool. I think we're on to win here. I do have some notes off screen to remind myself the exact OpenGL runes to summon this. But I think include graphics. Sorry. Utils error. And then we're going to not do that. We want to expect that so this is again narrow contract dot type is equal to the shader type vertex. Shader is not a vertex shader. This is an expect, so you can think of this like an assert. So this will be stripped out and release builds. So this is again just a courtesy to the caller that they've goofed. It's not part of the actual contract. I've not used CCLS yet. Yes, the stood for most docs. I mean, there's just a lot of like C++ mechanics around using it. It's great when you get it working, but it's kind of a fair amount of mechanics around it. Auto release you can think of it like a unique pointer, but it is for integer handle types or non-pointer handles. So everything in OpenGL kind of returns a gluint. So this will handle that. That's a good point actually. And you can provide a destructor or detour, whatever you want to call it, a deleter. But it is move only, it's non-copyable, movable, and has all the sort of requisite gubbins around it. So once we've done that, we can do handle equals. Can I just do GL create program and then GL delete program? I think so. There you go. So again, handle auto release. I can give it the output of this, and then this will get captured and used when it goes out of scope. So now I want to ensure handle. This is actually a runtime error if this fails. What's it return? 0, I think. Oh no, a minute. It's it's got an operator bool on it, so that's fine. Failed to create OpenGL. It's templated on an invalid type, so it kind of like compile time knows what an invalid value looks like. No, because I'm not instantiating it here. I don't want to call it. I'm basically passing in a reference to was it captured by a pointer? Can't remember what it's captured by, but I don't want to invoke it. I want to say here is the thing you should invoke when it goes out of scope. Function pointer. Oh, do I just stuff it in a stood function? You know what, actually, there's an easy way. I think you're right. I think I just shove it in it. Any callable that can be shoved into a function, a stood function will go there. So that technically does a heap allocate, or potentially does a heap allocation, but I'm not that fussed. I do envision potentially having to write our own stood function at some point if on a hot path we're using lots of them to guarantee small buffer optimization, but that's kind of way down the ways. Indeed, it do be type erasing, but you can do it with a small buffer optimization. The button has been clicked. Thank you. I completely forgot. Thank you, AC. It was on my to-do list and did not get to done. Just so excited to just jump in and start coding. And then I want to give this thing a name, don't I? Actually, so actually that is definitely a difference here. Let's do string view, and then let's do stood string view name. So I want to be giving these like semi-reasonable runtime names. that get baked into the OpenGL object, which is something we didn't do last time. Is it going to make a difference? I don't know. Is it more typing? Sure. Yeah, indeed, it should be more meaningful. Color themes. Someone want to bang theme that just for the engagement? I could say it, but the more comments, the better. So I should now be able to do GL object label GL program. Is that a tag? Is that a thing? I think it is. Shove in the handle, name.length, name.data, length end pointer, absolutely crazy. Nice, good one. Okay, so that's there. I think then I now need to like GL attach shader to the handle, and then vertex shade. So last time I was talking about the native handle, which is like my kind of inbuilt escape hatch, but getting actual access to the bits I need. Where have I got caps lock on? Where's all my code gone? Okay. I had a slight Vim malfunction there. Let's just try that again, shall I? Anyway, vertex shader dot native handle. This will give you the gluint that is inside it all out, and then there you go. So you can see, yeah, shader is compiled here already. So again, you cannot, because this checks the validity of the compile shader, you cannot construct a program from an invalid shader because that constructor would fail. And then GL link program. That should kind of, you could technically get away with that, but like it doesn't do the error checking that you think it should do. You have to go and manually kind of validate it. So I want to do auto res equals GL int, something like that, and then do GL get program IV of the handle, then do GL link status, and shove that in the result. I call it res, and then if res doesn't equal GL true, i.e. it did no linking, char log 512 GL get program info log handle size of log null pointer log. So this will basically query it and say, hey, what went wrong? And then I can do throw exception, failed to link that program, and then put the log there. Actually, I probably also should put the name as well. Sorry, questions? Yeah, we're not quite got to data yet, but I can't guarantee we won't. Shouldn't it be type and vertex fragment? I don't think so. I think this is right. That's certainly what we used last time. Anyway, yeah, I think is there bang setup. I don't know, but there is, yeah, I use NeoVim under WSL and tmux and MinGW and a Dockerized build system for this. Is it what you should use? Sure is what I'm using. Nope, I'm not using SDL. I'm doing it. We're doing that bit from scratch. So we've got our own window handling code, window creation code. We've got our own event handling code. Yeah, pretty much done that bit from scratch. It is NeoVim, yes. I've never used GeoValidate before in my life. What does one validate with that? What does that catch that this does not? GeoValidate program checks to see whether the executable contained in program can. Sorry, let me just read this. Let's read this together. Let's read this as a class. GeoValidate program checks to see whether the executable contained in program can execute given the current OpenGL state. The information generated by the validation we stored in program's information log. Says validation we stored as part of the program. So by this, so what did I read? Whether the executable can execute given the current OpenGL state. The OpenGL state is always changing. So does this mean I should be checking this before I use it, or do I just do this once in the constructor? Oh, is this ready to run? Okay, fine, sure, we can do that. I suspect I don't have GeoValidate. But there's one way to fix that. GeoValidate program proc. Yep. GeoValidate program go. So we do GeoValidate program. And then handle. Not that one. I got the wrong one. Oh yeah, well done. Oh, what a good spot. Help. Oh, we're frozen. Computer. Hello. Computer. Hello. Should I just run that? And I'm recording as well. Capital Q. Got to make sure we get that in there. Okay, fine. So now I've validated it. What does it say? The state of the valid parameter will be stored as part of the program's object state. This value we set to geo true if the valid. You can query by calling geo get program with arguments program and geo validates. So I want. So I think I basically want this. I kind of want this again, right? And I call it with GL validate status. And then it failed to validate program. I've written that code twice now, so actually, is this going to be easy to pull out? What's different? You need to pass in a flag and then pass in a custom string and a name. Yeah, that's not too bad. So auto check state gl enum enum state check, then stud string view name, and stud string view message void. I am indeed. I'm OpenGL. And then this can be UFPS. We're gonna need the GL uint handle. That's fine. And then that will then become message like that. If state. Vulkan maybe at some point in the future. This project will be purely OpenGL. I mean, I think as I kind of learn advanced OpenGL and figure that out, it might come to a point where I want to stretch myself again, but there's more than enough here to keep me entertained at the moment. So yeah, no current plans. Handle GL link status name fail to link program. Then this can come down here. This can go get rid of that. Do that. I do wonder if I should just like shove that there. I feel that's a little bit tidier. I've lonked again. Kind of tempted to keep it in there. Validate. Okay. I'm going to put a lonk on it. So I might need a command for this, but I'm kind of have to keep answering it. Have I lonked again? So this code will be from scratch. I have currently no plans to write an engine. Like I only want to write the code that means that services this game. It will be building upon some of the code we wrote for the last project, the last game. But again, this is going to have a whole new bespoke renderer, so there's going to be plenty of stuff to do from scratch. But stuff like, I don't know, the vector classes and the matrix classes, there's literally no, I think, merit in rewriting those. But we will port them over, review them, tart them up a bit, make some changes, but by and large we will pinch stuff like that makes sense. I don't know Rust, so I haven't got any thoughts on it, but like if you know Rust and you want to write a game, then sure, like that sounds like a great idea. And then I think this is just like, well, not there obviously, not a psychopath. Use program handle. So I think that's all we need. So an engine is like generic, right? So it means you could take that code and use it to write other games, which means it has to kind of handle lots of edge cases and be kind of fully fleshed out. Whereas I only want to write the bits that are required to service this individual game. So you would be able to write no other game with it, basically. If you want to learn OpenGL, then like learnopengl.com is kind of like the recommended, I'd say. But for the OpenGL version 3, I should say, Learn OpenGL is pretty great. The Oracle, because OpenGL is so old and there's a lot of training material on it, like the Oracle is pretty good. So if you ask ChatGPT, it will give you some reasonably sensible stuff as well. It kind of depends how you learn, I guess. Okay, so let's see if this. We haven't even, like, half an hour in, and we've not even actually built anything yet. Program. Let's just see if we can. So we should end up with a blank window if all goes well. Nice. Okay, so this is what we've got so far. So this is a Win32 window. We've built the window ourselves from scratch. It's got all the input handling from scratch. It's got a very basic loop. Obviously, it doesn't do anything at the moment. So, Luigi, I have somewhere a rough plan. I do have a rough plan. You might not seem it, but somewhere. I can't find the tab for it now. Sorry, I've got a load of stuff off screen. Where is it? So yeah, there's a rough, like we're doing hello triangle, and then we've got material system, model loading, deferred renderer, HDR, SSAO, FXSA, blah, 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 other 3 and 4 letter acronyms, decals, I want to do multi-threading, I want to integrate physics engine, blah, 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 animation, blending. So there's kind of a rough order that I'm going to be doing in, but I reserve the right to change my mind on a whim. It does produce some, oh yeah, it also does scrape some system information as well, which is quite nice. And that code's all there. You can see all that code now. That is, if you like, I mean, if you're brave, then look at the system info, because it is some absolute horror. It doesn't look too bad because we've abstracted a lot of it away. But if you want to brave some beastras, and you want your proxy blanket or whatever it is, what was that? Yeah, if you want to co-set your proxy blanket, then the code is there for you to do that. Okay, so let's see if we can. OpenGL is just an interface, which is a C interface. It's not really written in C because it's just an interface to a driver, but it does expose itself as a C API. Right, let's see if we can. Right, I think let's vertex pull to render a triangle with just GL draw array, and then we'll do the indirect one. Then we'll do persistent buffers. That's kind of my plan. Those are the 3 kind of big ASDO pillars I want to do as part of this. So we're going to need some vertex data, right? I think that's... Actually, before that, we're going to need a vector. So let's the source maths. Sorry if you're American, but we have multiple maths over here. Game. What did I call it? Did I just call it? Sorry, source maths vector 3.h source. Yeah, I'm not going to do. I'm going to indirect draw array, I think, just for the triangle, and then we can do that. We can index it later. Yeah, put your boots on the code. Source maths. Okay, so actually, this is a good one to look at because we wrote this vector class. One of the first things we wrote in the previous project, so it could do with a little bit of a tie up. I'm going to actually remove the vector 4 stuff now because we don't need it. I can't remember why we had to add that in the end, but what's interesting, I think, about this is we tried to make it all Constexpr because the more you can make Constexpr, like the more your compiler has the chance to kind of optimize for you, even if you don't realize it. But we used a bunch of math or CMath functions, and as of C++ 23, more of them have been made Constexpr, and GCC 15.2 does actually support that. So we should be able to go through and make a bunch more of this Constexpr. I think the only one that's not done in GCC is Hpot, so we might just roll that one manually. But let's see where we get to. So this should be able to now be Constexpr. Yeah. Nope, that one already is Constexpr. Ooh. Apparently I've gone for static Constexpr. I think it is in the standard. I just don't think GCC have implemented it yet, and I don't understand why they would have implemented all the others and not that. But we can try. Like, we can but try. Oh, is it 26? They made them more Constexpr. Maybe that's right. I think all these are just straight up Constexpr then. I think if it's Constexpr, doesn't that also give it, or doesn't that automatically give it internal linkage? I think that can be Constexpr as well. Oh, interesting. Okay, fine. Well, we'll see what happens when we try and blend this. Const is just a agreement that you enter with the compiler that you will not modify the data, right? That's literally all it is. It's just an agreement you take out with the compiler, a contract, if you will. Constexpr means that it is something the compiler can potentially evaluate at compile time. So what does that mean kind of in terms of variables? Like, they're kind of similar, but Constexpr is guaranteed to be evaluated at, Constexpr means it can potentially be evaluated at compile time. So you could use that as, say, the size of an array, which obviously the compiler has to know at compile time, unless you use that weird GCC extension, but no one talks about that. And then, so all these functions basically means the compiler can potentially evaluate these at compile time. So if it sees a bunch of vector addition, right, and it knows all the inputs, then the compiler can basically just collapse all those down for you. I thought Constexpr implied into the inline linkage. I could be wrong. And I don't think it's subject to ODR. But, well, you know what? When the whole thing explodes with an ODR violation, then we'll know that I was wrong. Const eval means that the compiler... So Constexpr means the compiler can potentially evaluate it at compile time, but it doesn't have to. But it has to have all the things inside it that would make it available to do that, but it doesn't have to. Const eval means it has to evaluate it at compile time. So there's a subtle difference there. Or VLA. I mean, why are you not just using templates at that point? Constexpr function is implicitly inline. That's cool. Okay, I thought that was the case. Right, let's also then copy out from. Let's get our previous, because I got a bunch of tests for this as well. Vec3 tests. So we'll stick that in our tests directory, and then this will tell us if it blends or not. Make tests, I want to say. Yeah, sure, I get that. Those 3 tests. So any vec4 tests can go away. If you've left the template angle brackets empty, then that means you have a full specialization of the template. But it still needs to know it's a template specialization rather than, say, in trying to do like a new type. So it still means you basically, it is a template, but you are specializing what it does given that particular argument. So let me see if I can find the good example for you. So this is a template, so it means you can give it any type T. Ignore this because it's default. You can give it any type T. When you do your, I really hope it's got an example here. What you're basically saying is, notice how you put the type here. So this is basically saying when you see a formatter with this type, this is what you should instantiate. Like this is the specialization for this, but this is just part of the syntax. You need to say this is still a template, but I'm fully specializing it for this type. You can have additional template arguments here, and then it's called partial specialization, but that's, make that really small. That's basically what that does. I can probably go over that again later on, if that makes sense. I used VS Code with the Vim extension for years. I think it's very good. Because it's cross-platform. Like, it doesn't really matter what platform I was on. I was like, boom, I've got Vim, like 90% of Vim bindings and VS Code, which is pretty good. Now I pretty much just try and stick to a Linux dev environment with like Windows or whatever on the outside. Okay, well that sure did run. Is that I think that's my expect death one, yeah. Did it run the vector tests? Oh, it did. Okay, fine. Well, apparently that is Constexpr. Oh, I don't know. Maybe because I've not tried to invoke it in a Constexpr context yet. VS Code is great because it's got loads of plugins. It's got great like dev container support. Like if you're into like Copilot and stuff like that, it's pretty good. It works everywhere. Like it literally works everywhere. You can have your settings all stored up on your GitHub account. So like what I really liked about it is I could get to a new machine, download VS Code, log in, and like everything was exactly as I wanted it. I got RAM to spare for Electron apps. Okay, so now we got this. Let's just comment some of this up because I feel like we are made quite a lot of changes so far. So add new OpenGL function, add program class, and then steady. Add vector3 class and tests. Okay, fine, cool, done. So let's do eSource graphics vertex data to H, and now FPS. Maths vector3. So we're going to have a struct vertex data. So this is what we're going to basically be pulling into it. Vector3. Oh, I didn't update the namespaces. No one saw that. No one saw, or did they? And I just was ignoring them. What? How did I miss? Where's that? Oh, I didn't put the G at the end. Oh, what a fool. Fool of a took. Okay, fine. Let's just quickly amend that as if we never made that mistake. Okay, fine. So now let's go to vertex data and then we do vector3 position. So that's going to be my vertex data, right? Pretty simple. I think if we're clever with the using float arrays in OpenGL with std430, this will just work. That's a lot of words. gonna be knee deep in vertex data. I guess we could like like that. Like if we want to be super paranoid to check that there's no extra padding. I mean, I could pragma push or whatever it is and set the padding, but I think that's kind of fine for now. This is getting out of hand. I'm gonna have to abstain from this conversation now before I get banned. Okay, so let's go to let's just shove it all in main. Like let's just shove it all in main. So effectively going to want. I've got some notes somewhere. Hang on, where was my notes and such? This is gonna. So this is the sampler vertex shader, right? That's gonna be the sample fragment shader. Well, I thought that the commit message and comment thing might get a bit out of hand, so I plan on doing maybe one every couple of streams to keep it under control. So I'm gonna want what do I want? That's my vertex shader. So actually, I'm gonna need to pull these in the vertex shader, aren't I? Is that right? I'm gonna pull them in because I need to send those to the fragment shader and have them interpolated, right? So this is gonna have struct vertex data. Oh my goodness. Could you please stop guessing at the formatting, please? Absolutely not. I think then I can do float position 3. Is that right? That doesn't do the weird padding or anything, because I think vec 3 gets padded to vec 4. And then I'm going to want to basically bind a std 430, which just sets the layout of the data. Read only buffer vertex data. Vertex. In fact, actually, I've changed my mind. Vertices. Vertex data. So an unbounded, unsized layout. I'm missing. Yeah, okay, cool. So this will then basically, so what this allows me to do is will allow me to upload an arbitrary number of vertex datas, which will look like this, which will match the CPP side. And then I can pull in via the vertex index which one I want. Basically means I don't have to have a VAO. So in, I guess, OpenGL 3, you bind your buffer data and you basically say, hey, at this index there's a position and it's got a stride and an offset, and at this thing it's got a UV and a normal, and then you bundle all that up into another OpenGL primitive called a vertex array object, a VAO, and then you have to bind that every time you draw. That's just a lot of churn and overhead and stuff, whereas this is just like, I'm going to squirt some vertices into the graphics card and I will tell you which one to use. Yes, exactly. You obviously, well, not obviously, but we do need an VAO, but like not particularly great one. Then, so the article I was reading suggested doing this. I'm gonna, this is what I've been following, by the way. Well, you think I'm making this all up as I go along. Yeah, position index and then return vec3 data index dot position. Sorry, got stuck for a second there. This just gives it to. I've got to type it there, haven't I? I assume this will get optimized down and reasonably efficiently. I think I got it. I think we're there. And then the GL position for the next one just becomes vec4 get position GL vertex ID 1.0. So the GL vertex ID is a unique integer that the driver supplies for you per index of for each. It will be the index of the vertex you're rendering. So if you're rendering 3 vertices, you'll get 0, 1, and 2, depending on which one it is. So this is how you can basically marry this all together. And then I think for here, for my fragment shader, is it GL frag color? Is that right? In fact, actually, I prefer a nice azure color myself. Oh, there's a newer version. I'll comment as I go along. I will probably do a lot of the commenting and tidying up off stream just because it's not as interesting. But yeah. You don't there is a fair amount of maths in graphics programming, so if you have some concept of what a vertex, like a vector is, and a matrix, and not necessary, but helpful like a quaternion, like at least conceptually what those constructs are, then yeah, it will help you. Yeah, and a bit of trigonometry. But I still think you probably potentially need to know just like conceptually what they represent and what they mean, rather than like the mechanics of how they work. But yeah, it depends on what libraries you're using. Have an output vec4. Oh, I see. So you're right. So what do I want? I want out vec4 like that. Is that what I want? I think if you try and come up with like a total list of things you need to learn before you get there, you'll end up getting quite stuck and frustrated. After a while, you kind of just need to figure it out as you go along. What's the runes for that? Is that like that? Or does that come after out? It comes after out, doesn't it? Is that right? Ugh, so close. So this is just basically specifying like where the color is going to go, and it's going to go like here. Okay, that's fine. I'm happy with that. So these are my 2 shaders. I'm going to take a bunch of data. I'm going to pull in each individual vertex. I'm going to send those across. And then I'm going to just color them a delightful azure to start with. And then we'll sort of flesh this out with color data as we go along. I think that's what I want. Right, okay, fine. So I think we can probably disregard this because I will very soon be using it. Simple vert, simple fragment shader, fragment. Oh, I've changed between sample and simple. Easiest one is just change this, I think. I don't know what happens if I try and tag this. Is it an error to give this two GL objects the same name? Interesting. Who's to say? Graphics. Right, let's bring in our fancy new program. Auto sample prog equals UFPS program sample fragment sample vertex sample fragment sample prog. That's my best kind. That's my favorite kind of behavior. Is one that just works and has become silently confusing. Those could be const as well. Pretty sure. Yeah, dedicated shader files are like down the line. I'm just because that involves like resource loading and some sort of like integration around that. And whilst it's not a lot of work, it's not the work I want to do today. Again, it's a great question, by the way. It's kind of part of my ethos for just writing the code we need right here, right now. And the code I need right here, right now is just to test we can render something. So this is exactly how we did it on the last project. This will eventually go away into dedicated files, and then those will be pulled in and loaded, blah 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 blah. But for now, like, let's just keep it simple. I think that can be const as well. Why are you not liking that? What have I missed? Pretty sure that's right. I mean, I guess we could make that string view, but it's definitely in that namespace. Let's just see what the actual compiler says. No conversion from basic string view. Have I passed it? Passed the strings in. That could be an alternative constructor for sample for program, as it takes the strings in and constructs the shaders for you yourself. It might be a slightly nicer interface. Oh god, shorts. I was meant to be making timestamp notes as I go along of things I've said. Did I say something useful there? Was that important? Someone write a timestamp, quick. Someone write a timestamp, quick, in the chat. Everyone's fucking panicking. What is time? Good one. I like it. It's exactly what I would have typed there. What am I doing with my life? Oh, I need a buffer, right? So let's do that. Indeed. Okay, fine. So now we need to, there's basically two things left to do. There's create a buffer such that we can upload this data and bind it. I think you can't, I'm pretty sure you still have to bind it to like the SSBO slot here. I don't think there's any way around that, but I still need to construct a buffer, squirt some Vertex data into it, upload it to the GPU, bind it to this, and the second one is to pull the trigger on rendering and hope for the best. Okay, fine. So what am I going to do? I'm going to need a buffer. I'm going to pinch the buffer from the last one, but we're going to review it because I think there's some stuff I want to change. Yeah, okay, fine. So this is the first thing I want to change is so in the last stream, we had an awful lot of std vectors, std bytes, and then std span of const bytes. Normally, I am a big fan of being explicit with the types, but I think we are going to need, again, a lot of like, here's a blob of bytes, and here's a read-only, non-owning view over them. So what I'm tempted to do this time, and I don't normally do this, but I think it might make the code slightly, it'll be certainly less typing. Utils, source util. Let's do e source utils data buffer.h. No. It's not gonna be C. It's still gonna be proper. Still gonna be proper code. What I'm thinking is something like using data buffer equals std vector of std byte, and then using data buffer view equals std span of const byte. I don't normally alias types like that because I prefer the actual things, but I think I'm kind of also, it does mean we could potentially provide a custom allocator here and have that apply everywhere, which would be nice if we wanted such a thing. Your view of custom allocators notwithstanding, I'm gonna try this out. I reserve, as always, I reserve the right to change my mind later. So now this just becomes, it's all gone. Data buff. I want a better naming convention for this project. I want more things that are like the thing that owns it and then a view. So I really want like a texture and a texture view and maybe like a model and a model view, just to be really explicit on this is the thing that owns it and this is the thing that is you should be passing around just like the non-owning like read-only view over it. No, I mean, no one enjoys templates. I'm not sure if I really enjoy templates. Like, I mean, I kind of do, but they are tricky. So don't let it get you down. Okay, fine. So I think this is basically all I want now. As an interface, right? So you create a buffer. It will construct the buffer for you on the. It will allocate some space for you or reserve some space for you on the graphics card, and then I can use write to it using some non-owning view of bytes. Am I? I didn't realize that. Who's raiding me? Hello. The size of std span will be probably 16 bytes. It'll be a pointer and a size. A size T, so it'll be 16 bytes. So I'd say it is small enough to pass by value and not worry about it. Oh yeah, Wolber, where it rated with 47. Sorry, I was in the middle of explaining something and I missed that. Hello, everyone. Enjoy. Yes, apologies if I missed that. I was deep in the throes of something. Okay, fine. Let's bring over our actual implementation. Without trying to leak all the projects that I work on with the fish autocomplete. Graphics buffer.cpp source graphics fg. Because like I like Windows, like all my stuff works on Windows, and I want to ship a Windows game. I know maybe this is unusual, but I don't really have that strong opinion on operating systems. Like, it's a thing that I just use and kind of get on with my life. It's not a massive part. It's not a lot of time. It's not something I spend a lot of time thinking about. So this is all good. So again, auto release here. You create the thing. We've got the named buffer. This is all fine. It's got that many bytes and stuff. And then there's be data buffer view, which means I can now bring in hash include utils data buffer. Okay, fine. I would say this should actually be expect. Let's not narrow that. Let's keep that contract narrow. Let's not artificially widen it. Again, this will probably go away with persistent mapped buffers anyway, but for now, like, we're good. I'm trying to draw a triangle. That's literally my aim for today. And then like ramp up the modern, quote unquote, modern OpenGL-ness of it. Okay, fine. Let's go to graphics. Let's slap this in here. Buffer. Just a wafer-thin buffer. Check this blends. Indeed, we've got to start somewhere. Got to start with the triangle. Okay, right. So that blends. So now I should be able to construct what I need to. What's me hello world triangle look like? What's my main? Okay, fine. So let's bring in everything. Let's just hash include the world. Graphics. Buffer. Sorry, I got stuck for a second there. Hash include utils data buffer. I think that's what I need. Indeed, this is true, muzzle. Okay, fine. So that's... Oh, and actually I need the vertex. Vertex data. Okay, fine. So let's do const auto triangle equals UFS const UFS vertex data triangle equals I think I want 0.0f 0.5f 0.0f and then when doubt, just add more curly braces. -5, -5. I'm just copying this off. I had this written down earlier because I knew I was going to need it. Does that look like a triangle? Do we think that's is going to triangle? I'm going to now engage in some light undefined behavior. And that I'm going to have a const auto triangle view equals it's got to be done. Data buffer view reinterpret cast Oh no, wait a minute. No, it's not. Of course, it's not. It's the byte. It's not. It's entirely well defined. Sorry, having a mab on there. Triangle. Size of triangle. That's fine. That is well defined. Yeah, sorry. I was that is legit that. And then we do const auto triangle buffer equals UFPS buffer size of triangle. And then we should be able to do triangle buffer dot right triangle view 0u. All right, I think that's right. So we construct our triangle data. We get a view of the byte of the underlying bytes. We construct a OpenGL. We allocate some memory effectively on the GPU. We create an OpenGL buffer of this size, and then we just squirt those bytes straight into it. You have training commas down. Yeah. Because that stops the some of the formatting. Okay, right. So now I need to. Is it just GL draw? Oh, don't I need my empty VAO? Yeah, it'll compile. He says. I've said that with absolute confidence. Yeah. And then I need my like yeah, auto dummy VAO equals UFPS auto release GL uint and then GL gen vertex arrays 1 dummy VAO. That's got to be 0 and GL delete vertex arrays. Yeah. Is that not right? How did I do this in buffer? Why is that a lambda and I didn't do that? Did I not have to make that a lambda in other ones? Whatever. One second. Oh, sorry, I've got to find something quick. Okay, fine. Sorry, I've been asked to look for something. And then this would be what? Auto E and then E that. All right. Why is this? Why am I struggling with this? Template on GLUint, and then you just construct it with that. Hey, what's going on? What have I missed? Too few arguments called. I mean, I could just not use auto release because we're going to create one and we could just leak it at the end, but I feel like it's not what I'm about. Oh, this isn't helpful at all. Have I got too many? No, this isn't the issue. I literally can't see what I'm doing wrong because, like, look, if we get buffer up next to it, which is exactly the same paradigm, I construct that here. Auto release GL uint. Auto release GL uint. Oh, am I not passing the right? Isn't it going to be 1? There you go. No, okay. And then that. Okay. Whew. Got there in the end. I will have my braces back. Thank you very much. No, I was just invoking the destructor wrong. But this is not. This is not it. This is not a great example of this is not. You would not use this to convince someone to use C++. Yeah, exactly. Yeah, it's kind of percolating up, but still annoying. Okay, fine. So we've got that. Then we just need to. I probably just bind it once, right? I do use lots of autos, yeah. Well, let's just do all the rendering stuff here. So we're going to do program. Was it sample prog.use? And then I need to bind the SSBO. What's the runes for that? GL bind buffer base GL shader storage buffer 0 triangle buffer dot native handle. Not that many lines of code, like literally not many at all. Do I need? Can I just do this like once up here after I bound this? Because I'm gonna have to do GL bind vertex array WVO dot get. Oh no, I should be able to do that actually. Yeah, sorry. What if I can just bind that there and then do I have to have a program in use before I can bind it? Yeah, of course, yeah, but just for now. So we're going to use the program. In fact, actually, the program's just in use for the entire thing, isn't it? Which bit do you think is overcomplicated? I'd be curious to know. Maybe I can help, like, defend it. I mean, like, maybe I can apply some, give you some, my thought process and justification. This is just near them. Okay, fine. So now I want GL draw arrays, GL triangles 0, and then It's a 3, isn't it? I don't know, I'm trying to be clever. I think we should take a poll. What do you think? I think we should poll. I really like doing this on both Twitch and YouTube because it's really fascinating to see which of the services is more pessimistic about my ability to write code. I mean, there's a fair amount of boilerplate with OpenGL, but you can kind of nicely push that behind like a couple of primitives and then not have to worry too much about it. Right, 5 seconds left remaining. Afraid not, no. Right, okay, let's... How do I end the poll? End poll. So we have... I literally cannot see any of this. So 100% of people on Twitch think it's going to work first time, and only 64% of people on YouTube. I will concede maybe minor shader. Like, if the shaders don't compile, then I would not count that. I think if everything aligns, like if it gets to the render command, basically, then it will render. Hang on, sorry, I've been lost something. No, sorry. Sorry. The suspense. Okay, let's give this a go. Oh, boom. Nailed it. Oh. Always works first time. Okay, right, let's comment this up because I think this is a good place, and then we're gonna see if we can maybe do the indirect rendering. Or maybe add colors. Oh, don't know. We'll see what we get to. Definitely don't have it. Sorry. Right. Okay. What do we do? We added a buffer class and a vertex data class. What's the order of this? Let's do add data buffer primitives. Add vertex data struct. Add buffer class. Render triangle. I kind of finished it. Like I think I took the barrel game, the puzzle game, about as far as I could. There's some architectural issues, not necessarily issues, but there's some things were a little bit hard to work with, and I was just kind of ready for a new challenge. I think we kind of wrapped it up in like a reasonably good place. I don't feel bad for where we left it, but it was time to do something new. Okay. Yeah, we want to use more modern OpenGL and deferred renderer. I think maybe like the two tenets of this project. Okay, fine. What's next then? I do what I need. The other thing I want to do is I want to get DRM GUI integrated like as soon as possible. So I think we'll do. Let's push forward with the render tech. So the next thing we want to do is like. This isn't great because you would need to call this for everything that you want to render. Okay. Oh no, I'm just gonna download the ImGUI project again like last time and just slap it in. Yeah, no, I'm hoping I can just use it just to emit some frame buffers and render it. So use DRM GUI, I guess, is probably the correct answer. This is the correct statement. So the issue with this is that you have to call this per thing you want to draw, which necessitates some overhead. What we want to do is upload again to a buffer a bunch of draw commands and then just say execute those commands. So the idea is that you rather than on the CPU side saying like render this, render this, render this, render this, you push into the GPU a bunch of instructions for it to render and then say render all those instructions. So that's probably the next thing to do. I think there's some delightfully named functions that we now need to look at. I think what I want is, and correct me if I'm wrong, yes, exactly, yeah. I think I want this GL draw arrays indirect. So we're going to stick with effectively drawing arrays, and then but we'll have a pointer to the draw parameters which we've uploaded to the GPU. I've never done this before. This is brand new territory for me. So we'll see how it goes. See if we can get this. If we can get this done in the next half hour, I think that'd be a pretty good place to leave it, because then the only thing to do after that is persistently mapped buffers, which I don't think will take too long to do. And then we kind of got the I guess like the three big bits done. Then, like once you can render one triangle, we can render them all. I think this is the one I want for now, right? Yeah, exactly. I think this is just to kind of prove out building out the command buffer, uploading that, the mechanics of all that. Yeah, so this will just shift the draw parameters over to the GPU, and then when we want to draw multiple things, there's a whole family of these. I think we want the multi one, but for now, like again, I think there's value in doing baby steps, and then we can do multi. Or do we just do multi now so I can then render two triangles? I think actually I might just do them straight to the multi one. Arrays indirect. Render index primitives. No, I don't want index primitives though. Draw elements. Is there an array one? I don't. My goodness. There's so draw multi draw arrays indirect. That's what I want. Render multiple sets of primitives from array data, taking parameters to memory. Yep. Okay. Right. This is the one I want. This is the one I want. Let's go. Gel. All right. See if I can get this right. GL multi draw arrays indirect proc. GL multi draw arrays indirect. Okay, fine. Oh, that's count. I don't want that. Not yet, anyway. Yeah, okay, all right. Everyone harass me. I've seen it. I've seen it. We all make mistakes. Yeah, we'll still have to call it every frame, right? Which would be for every loop. Okay, so now I've never done this before. So what does the here you go? Is it in the is in the article, right? Here you go. The parameters addressed by indirect. Especially just. Oh, interesting. So does this point to CPU memory, or does it point to GPU memory? Like where specifies the address of an array structure. Address where? So does this upload that for me? So this is the parameters addressed indirect packed into array of structures. Each element is so the count, the instance count, the first, the base index. A single call to GL multi is equivalent, assuming no errors, equivalent to this. So you can see here it runs through and draws these. Okay, so I assume for now I just construct this in an array and point this to it. Can I have the whole thing in GPU memory eventually though? Surely you can, because isn't that how you do compute shade culling? GL draw. Is that a different function again? If a buffer is bound to the GL indirect buffer binding at the time of a call, indirect is interpreted as an offset in basic machine units into that buffer, and the parameter data is read from the buffer rather than from a client. Oh, I see. Okay, so actually I can. So can I create another buffer, bind it to the GL draw indirect buffer, and then just use that? Right, okay, fine. Let's just do that. That sounds a lot easier. So we will have a... Let's copy this. CPU memory is dead. I want to use that sweet, sweet GPU memory. It's dead to me. Well, that's not what I wanted at all. Eh? Okay. What is going... What? Why have I got phantom... Something strange is afoot here. Also, don't need any of this C-style nonsense. Indirect command. Okay, so I'll have one of those. I've got to figure out what all these mean as well. I assume I'm just going to have one command, right, to draw an triangle. Yeah, exactly. Okay, fine. Right, let me cogitate on this for a second then. Let's so let's do const auto command buffer. Oh, getting close to Vulkan now. U FPS buffer, and that will be size of indirect command. So I'll have one of those, please. I will then have const auto command equals a indirect command, and then whatever the hell all these things are. So count, I don't know, 1. I'm literally just making this up as I go along. Instance count 1 first. equals naught. I'm going to look at what these actually are in a minute. Base instance equals naught. Okay, let's have a look. What the hell does all this mean? So the parameters is it going to tell me what they are, or is it just going to be like, you should know what these are, you fool? Like, okay, oh, that's only fine. Can you just tell me what these mean, please? Structures. Each element which has, oh, do I have to decode it from there? Oh god, right, okay, fine. So if you're doing draw count, which is, oh my goodness, that's fine. Yeah, you're right. It's whatever the arguments are for this. So it specifies the starting index in the enabled arrays. Specifies the number of indices to be rendered. But I'm not rendering indices. This is very much non... Count is vertex count. Okay, fine. That makes sense. So that'd be 3. I'll have 3 of those. How many instances? 1 unless you're drawing instance. So 1 is fine. First is the first value of GeoVertex. So you set 0. Is it? Okay, fine. So it's actually pretty close. Can't be having any of this. I mean, GeoDraw is boring. I need the added complexity in my life. I want to render everything with a single draw call, basically. So I'm going to have an Uber shader, right? So just like the whole lot in one. Well, there might be different layers because I might split out static and dynamic geometry, but like very few render calls. Okay, fine. So we stick that in there, and then I'm going to do const auto command view equals FPS data buffer view reinterpret cast constant by start of command size of command. That's fine. Do command buffer dot write command view 0ZU. Oh yeah, that's not working, is it? There you go. Right, okay. So allocate some space on the GPU, create a single command to render, turn that into a pointer, use that pointer and squirt it into the GPU. So after line 106, this data is now in the GPU. So now I've got to do some dance with binding this to a thing and such, which actually probably is basically here, right? GL... Is it just GeoBind buffer? And that into GL draw in... Oh, it's not like in this. It's not like in this enum. Indirect buffer command buffer dot native handle. Oh no, fine, it's accepted it. Okay, so that bind that to that, which means this now unlocks this bit, which means I can now, I presume I want the offset at 0. GL multi-draw mode gel triangles null pointer draw count 1 stride 0. I assume this is just going to tell it how many, this number here is how many effectively arrays of, how big the array of these are. I mean, still there, but much more efficient. There is no command buffer count because that's not exposed by the API, and this is just a single one. Like, yeah, this could be a std array, and I could get the size from it, or just an array. You are correct. Oh, it's just. I don't understand, mate. It's all in the docs. It tells you what to do. That make file actually secretly just pops up an image of a pre-rendered triangle that I did off screen, and none of this actually works. Yeah, exactly. Well, I think my plan, such that it is to I want to go absolute ham on abstracting this and make it multi-threaded. So you give it a scene, and the scene, because you can build this with multiple threads, right? So I want to be able to basically have a thread pool, have a scene, just throw it at that, and it just fills it out. Yeah, my way of reporting errors is the correct way, which is an inflammatory comment, I know, but I use exceptions basically for, if an error happens, an error is just like an ability to meet post conditions given valid preconditions, right? So if that happens and there's no meaningful way to recover, then I throw an exception and then it's someone else's responsibility to handle it. Yeah, indeed. Okay, fine. That's if the correct place is to handle it immediately in the above scope, then sure. Like that, you can kind of get, there's a bit of a nuance around that. Okay, add OpenGL function indirect rendering. Okay, I feel like the final thing we should do is, got a bit of time left. Actually, that took much less time than I thought. I don't think I'm going to do persistent buffers tonight, just because that involves triple buffering and like frame count, and I think it's just a little bit more. It's a little bit more work than I want to squeeze into the last 15 minutes. But I think we can maybe add in some color. I think that might be fun, and maybe even have that color update. So that's name source graphics. Where the hell is color in my previous maths? Pretty sure I had a color class. Utils? Oh, just straight in the source hole. Color graphics, I guess. That's basically all I've got. I will probably need to add an alpha channel at some point, but for now, we don't need to go to our vertex data. Hash include graphics color, which is nice, plus size of float times 3. Cheeky. The thing that we were looking for has been found. Whew. Crisis averted. Namespace name. Yeah. Okay, fine. Okay, fine. So let's go back to what's nice about doing this as well, I think, is that we can now start pulling this out and abstracting it, which I think is actually quite a lot. It's normally quite a lot of fun, and I think it's a value people find from some of these streams as well. Is how I kind of decompose these things and try and not make too much of a mess of it. So now we can have float color 3, and then what? Oh, computer, hello. And then I got to interpolate that. So is that an out parameter from here? Is that like out vec3 color? Is that right? Yeah, we'll always be programming. Is that right? Is that I can't remember how you SV means it's string view. Of course. Yeah. Yes. So layout location equals naught. And then is it in? Literally, it's been so long since I've written shader code. And that's got to be layout location equals naught, like that. Two colors now? Oh, yes, I see what you mean. Yes. Good spot. Nailed it. So this could be also, I guess, for fairness. Okay, fine. So now we've got the color coming in to that, this, that, and the other. I really, really want to reflect this out. Like, how sweet would it be if you could just give it a struct like this, and then it would use reflection to auto-construct the shader code to have like this, and then all these methods here. Oh, that'd be so nice. Soon. That is... Well, it'd be C++26, right, if you want reflection. And I need to wait for someone to implement it. But if GCC roll out support for reflection during this project, I will happily burn a stream or two using that. Ah, well, alignment be damned. Just pad it, mate. So this can be like, didn't I have like FPS? I'm just going to include it. Oh, hang on, missing it. I don't know. Of course, yes, it's colors. Right. First person to respond with their favorite RGB float-based color, I will include. I've got my favorite in there. Outrageous. I'm going to go with the first one that I actually want to put in there. Someone thinks they're so clever saying it should be black. And then we'll go for 0.42, 0.42. Good one. Grey. Lovely shade of grey. Yeah, alright, well, we're all hilarious, aren't we? I don't know, it's not too bad. I know, right? Degenerates. As our Prime Minister would say. Okay, so I wonder if I can... Presumably I can just change this by just rewriting it, because this data buffer view will remain valid over that data. So if we do... I don't have any lerp. Is there like is there a std lerp? There is a std lerp. I mean, if you want to make games, like if you just want to make games, do not do what I'm doing. Like grab an engine, grab Godot, grab Unity, grab whatever, and just like start making games. If you want to learn how rendering tech works, then I'm big advocate of OpenGL. I think that's kind of a good way to get started, or like maybe DirectX 11, I guess. No, it's just gonna be single player. Yeah, Raylibs is another good one if you want a bit more low level STL. Let's fine. Let me just try something. What am I doing? AI. It's R1 equals 0.0f. Auto R2 equals 1.0 f. What am I trying to do? What I want to change a color over time. Actually, no, it's a lot easier way of doing this. Auto delta equals 0. Sorry, my brain's gone dead. Right, let's try it again. Let's just see if I can get one of them to change first, because it's really not an important thing to do. Triangle naught dot color dot r plus equals 0.01f but 1f if triangle naught dot color dot r is greater than equal to 1.0f triangle naught. This could have been a reference equals 0.0f. Okay, fine. Let's just do that, and then we'll do triangle buffer dot right triangle view naught ZU. Whew, that was painful. Auto means yeah, it will deduce the type based on the thing you're assigning into it. I got off by one error. See if it, I just want to just like have something. There you go. I just wanted something. Like we could then flip it so it then subtracts it, so it kind of ping pongs between them. I just wanted just to see some visual effect. Yeah, so like auto, I mean, it just follows the template type deduction rules if you're familiar with those. But it basically, yeah, it will just deduce whatever the type is on the right. So it's as if I wrote UFPS shader there. I just can't be bothered. Yeah, I think that's pretty good actually. Let's add. Oh, we can all watch the GitHub actions together again. Add color to vertex data. Flash vertex color. Let's push that up. And I will find. No, not really. It just kind of flashes, but I think it'll be fine. Right. So let's prepare pull request. Triangle. It's going to be a patch update. Look at those commits. Sure, looks good to me. I've done a thorough review of all the code. Looks good to me. Let me just actually just check make test still runs, because it's a massive pain if it doesn't. Create pull request. Oh yeah, I will try and remember to tag it. Yeah, that's a good point actually. For tag. Try and spell it right this time. Stream 2. Thank you. Okay, fine. So this should now be building the jobs. So this builds it on Linux, then shoves it over to Windows to run the tests. Quite a few people today. I think we might try and let's have a whilst this is doing. Let's see if there's anyone to raid on Twitch. As we are wrapping up now. Anyone doing C++ things? I don't know why I just clicked there. No. Not a single C++ streamer on Twitch. Oh, no. Someone using Unreal. That might be as good as it gets though. I've reached the bottom. Oh, I did just see someone actually. It's disappeared. Okay, let that build. Sorry, I'm just killing time. Nightly C++ session. Interesting. Okay, so this will build it. This will hoof it over to Windows, which will then run the tests, which is nice. So those will pass. That's that. Okay, cool. So now that this is green across the board, going full enterprise, we merge that. That will then kick off the action to bump the version, which sometimes doesn't work if it's a bit too quick. Yeah, that's so annoying. That I need to see if I can put in some sort of delay there, because this will rerun jobs. I will ask the Oracle. There you go. And I need to fix anyway, because the summary message for the release is just the bump commit, and it should be all the commits. Okay, fine. So that's bumped the version. So this you'll see now. There's now a new commit at the top by the bot, which says it's now bumped the version, which is nice. And then this will go through and finally do a release. So this will now rebuild it once more with the bumped release, run cpack, stick it in GitHub release, and then send a message over to Discord. Right. There's no one CPPing, I don't think, today, so we'll save the raid for another day. That was good. I think we got quite a lot done there. Thanks. We're waiting for that. So next stream we will do the persistent buffers and then triple buffering, which is basically the last few bits I think we need. And then it's just a step up from there. So we'll go from a triangle to 2 triangles. We'll go from that to a cube. We'll go from that to textures, I suspect. Or probably cube to lighting to textures, because I want to do bindless textures. So everything will just be pulled into the Vertex shader. Almost nothing will be bound. Material system, so we can kind of tweak all that. We'll slap him GUI in there, so we can kind of select like, oh, I want this normal map and this specular map and this blah 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 blah, and then we'll just build out a bunch of that. We'll render like a load of boxes with like a load of different stuff, and then we'll do model loading, and then we're basically done. Thanks. Yeah, I vibe coded the whole thing. I don't really know how any of it works. I literally got the Oracle to do it all for me. If that makes you feel any better. That's the GitHub actions, by the way, not the C++ codes. That's unfortunately all from my brain. Ding, right, new version. Feel free to have a play. I don't know if it's any good, but it sure is there. Cool, right. Thank you very much for coming along. I don't... There'll be free goodies, the free membership subscription things in the next stream. Yeah, I mean, like, guns and physics and stuff is easy. Someone subbed AC resub with Prime, thank you very much. Yes, I'm going to have a bit. I'll hang around a bit on Discord. I'll try and remember to cut some of this up into shorts if I can find anything. Oh, we got a... Hi, someone gifted some memberships on YouTube. Thank you very much. How kind of you. Thank you very much. What kind gesture? I'll wait for that to play out. I will just sit here awkwardly and watch the little animation that I paid for play out. I didn't see how many it was. 5. Thank you so much. Thank you, Harand. Very kind of you. I didn't actually see it was you, but thank you. I wouldn't have been so pleasant if I'd seen it was you. Yes, it is uncensored. That's about as good as I could get. Cool. Have a play around with the code. Come over to Discord. Ask any questions. I'm happy to help answer them. And I will see you all Wednesday.